Welcome friends. Today we will discuss the unit number 4 of the subject electrical machine design, which is design of three-phase induction motor. This unit belongs to the section 2, and this is the first unit of the section 2. And in this video we will recall about the construction and basics of the three-phase induction motor. As all of you already gone through this topic, here we will take only a short review about the construction and basics of three-phase induction motor. Friends, as all of you know, the design is nothing but the procedure in which one has to decide the economical and efficient dimensions about the various parts of the machine. In other words, we are giving shape to the concept with the application of science and technology so as to get the required performance and characteristics of the machine. In this perspective, it is very important that one should know before starting the design various parts and their functions involved in the machine. Friends, we have already discussed in the class about the design of transformer and design of DC machine, and now the design of three-phase induction motor is simpler if one should know how to design the DC machine at a given constraint, because like the DC machine, the induction motor is also a rotating type of machine. So many design constraints are similar in induction motor and DC machine. Now let me start with the video. Friends, this is very important machine because this motor is most widely used motor, electrical motor, amongst all type of motor. We can understand this as almost 80% of the mechanical power developed in the industry is provided by this three-phase induction motor, and about 95% of the mechanical power used in the farm sector is developed from this induction motor. Now the question is, why this induction motor is so popular amongst all type of motors? Because it has several advantages. Like, it is very simple in the construction, as it involves very less number of parts in the construction. Its size and cost is also very less. It gives a better characteristic under the load switching operations, and it has a good speed regulation also. And because of all these advantages, this induction motor becomes most popular motor amongst all type of motors, especially as compared to the DC motor. And this three-phase induction motor works on the principle of or works according to the Faraday's law of electromagnetic induction. If you want to understand this as compared to the DC motor, in case of DC motor, supply is given to the stator, which we are generally saying field circuit, and also we are giving supply to the rotor, which we are saying armature. It means in DC motor we are giving supply to both stationary and rotating part of the machine. But in induction motor we are only giving supply to the stator winding, and EMF is induced in the rotor due to the induction. If you want to clearly understood this, then the working principle of three-phase induction motor is, when we are giving a three-phase supply to the stator winding, the stator winding produces the rotating magnetic field. And due to the relative speed between the rotating magnetic field and the stationary rotor conductors, the EMF is induced in the rotor conductors. The rotor conductors are constructionally short-circuited in nature. Therefore, as soon as the EMF is induced in the rotor conductors, this conductor starts to carry the current, and that current produces its own flux, which we are saying a rotor flux. It means at this moment there are two fluxes available in the air gap. One flux is the flux produced due to the stator winding or stator conductors, and another flux is the flux produced due to the rotor conductors. And according to the Lane's law, the rotor flux opposes to the stator flux. And in order to this, the rotor flux are always trying to minimize the relative speed or the speed difference between the rotating magnetic flux and the rotor flux, and due to which rotor flux and rotor starts to rotate in the same direction of the stator flux. As all of you knows that the speed of rotating magnetic field is called as synchronous motor, and we have already discussed that the rotor fluxes are always try to minimize the speed difference. It means the rotor fluxes never runs at the rotating magnetic field. So the rotor of the induction motor never rotates at the synchronous speed, and because of that the induction motor is also called as asynchronous motor, because the induction motor never rotates at the synchronous speed, or you can say the induction motor always rotates below the synchronous speed or other than the synchronous speed. Now let me start with the construction of the three-phase induction motor. The three-phase induction motor construction involves two main parts called as stator and rotor. As the name indicates, the stator of the induction motor is a stationary part of the machine, and rotating part of the induction motor is called as rotor. Again, the rotor is usually classified into two categories. The first is called as squirrel cage rotor, and another is wound rotor or the slip ring rotor. And depending on which type of rotor is used in the induction motor, the induction motor is classified into two categories, namely squirrel cage induction motor. So obviously in the squirrel cage induction motor, the squirrel cage type of rotor is used, and another is a slip ring motor or wound rotor motor, in which the wound rotor is used. So the construction involves only two main parts, stator and rotor has again two parts, the squirrel cage rotor and slip ring rotor. Now let me discuss in short about all these parts one by one. Now let me first start with the stator. As I already told that the stator is the stationary part of the machine, and the stator consists of three main parts. The first part of the stator is the stator frame, then the stator core and the stator winding. So the stator is normally made with these three parts. Now what is the stator frame? Now you can see here, this is the stator frame. Stator frame is the outer part of the induction motor. You can see here in the picture, the stator frame is the outer part of the machine. And its main function is to support the stator core and the field winding, and also it acts as a protecting cover and gives the mechanical strength to all inner parts assembled on it. The frame of induction motor should be strong and rigid, as the air gap length of induction motor is very small. Then the next part of the stator is the stator core. So this is the stator core. You can see this. Here is the stator core. The main function of the stator core is to carry the alternating flux. And in order to reduce the eddy current loss, the stator core is laminated one. And the laminated type of structure is made up of stampings with the having 0.4 to 0.5 millimeter thickness. And all stampings are connected together to form the stator core and housed in the stator frame. And you can see in this picture, the outer periphery of this stator core is slotted, and the conductors are normally housed in these slots of the stator core, and they are connected to each other and forms the winding called as stator winding. So the third part of the stator is the stator winding. So you can see here is the stator winding. So here is the stator winding. You can see here the outer periphery of the stator core is slotted, and the conductors are placed in the slots which are joined together to form the winding. And this winding is either connected in the star or delta, which is totally depends on which type of starting method we want to use. And this winding is also called as the field winding, because when we are giving a three-phase supply to the stator winding, it produces the rotating magnetic field. So that's why the stator winding is also called as the field winding. And obviously the main function of the stator winding is to produce the rotating magnetic field, which is very important for the further operation of the induction motor. Now after the stator, the next part is the rotating part of the machine, and it is called as rotor. As we have already discussed, the rotor are two types: squirrel cage type and wound type, or the wound rotor. And if the squirrel cage rotor is used in the induction motor, particular induction motor is called as squirrel cage induction motor. And if the wound rotor is used in the induction motor is said to be a wound rotor induction motor. Now first we'll discuss about the squirrel cage type of rotor. So this is the squirrel cage type of rotor. This rotor is a cylindrical in shape and have the slots on its outer periphery. And the conductors are placed in these slots. You can see in this picture, the slots are parallel to each other, but they are slightly skewed, and because of that its name is squirrel cage rotor. And skewing of these slots are preventing from the magnetic locking of the stator and rotor teeths. So in order to reduce the magnetic locking between the stator and rotor teeths, usually the slots which are created over the outer periphery of the rotor are slightly skewed to the shaft. So its name is squirrel cage type of rotor. And this rotor consists of the rotor bars. So it means the slots are not housed with the winding, it is housed with the thick copper bars. And these bars are short circuited at the both ends by a metallic ring called as end ring. So in this picture you can see here the all conductors which are housed in the slots are short circuited at the one end with the one copper ring, which is called as the end rings. So I have already told in the first slide while explaining the working principle of the induction motor that the construction of the rotor is short circuited in nature. So here we are short circuiting the all conductors housed in the slots through the end rings. The main advantage of the squirrel cage induction motor is it's very simple in the construction, and as the winding is not involved, the maintenance of this squirrel cage induction motor is very less. So it has a very rigid construction. Also, because of absence of the winding, the cost of the squirrel cage induction motor is comparatively less than the slip ring induction motor. Now we will look for the slip ring induction motor. Now you can see here this is the slip ring induction motor or wound rotor induction motor. So main difference between the squirrel cage induction motor and wound rotor is this rotor is having a winding wound in the slots of the rotor, and like the stator, the winding is connected usually in the star, and the three terminals of these windings are connected to the three slip rings, which are metallic rings connected with the same shaft. So that's why this wound rotor is called as slip ring induction motor. And this particular construction of the slip ring induction motor allows the facility to add or connect the external resistance in the rotor circuit. So the external resistance we can add in the rotor circuit with the help of brush which are connected to the slip rings. So this is the brush assembly, and the brush is the stationary part, whereas the slip rings are mounted on the same shaft of the induction motor or a rotor. So the slip rings are rotating along with the shaft. So just it is very difficult to give the supply or add the resistance in the rotating part. We are adding the external resistance with the help of carbon brushes which are mounted over the slip rings. As we know that the torque developed in the induction motor, especially the starting torque, is proportional to the external resistance or the value of the rotor resistance. So if we increase the rotor resistance by adding some external resistance into it, the starting torque developed in the motor will becomes high. So for that purpose, the squirrel cage induction motor is not allowing this particular construction, that in which we can add the external resistance. So once the squirrel cage induction motor is manufactured, we cannot change its rotor resistance. So therefore this induction motor is having certain limitations. Squirrel cage induction motor is having certain limitations for the torque applications. But here in this slip ring induction motor, we can very easily change the starting torque and the torque developed in the induction motor just by varying the external resistance. And therefore usually the slip ring induction motors are used where the application requires high starting torque. Now if you want to summarize this about the slip ring induction motor and the squirrel cage induction motor, then you can see here the slip ring induction motor is complicated in construction. The reason is the slip ring induction motor is involving a winding, brushes, slip rings, whereas the construction of the squirrel cage induction motor is very simple, as it has only thick bars grooved in the slots, and those thick bars are just short circuited with the end rings. So it has a very rigid and very simple construction. Another point of comparison between these two motor is the rotor winding in the slip ring induction motor is similar to the stator winding. So either we can build this rotor winding in the star or delta as in like the stator, but usually the rotor of the slip ring induction motor is connected in the star only. But the rotor of the three-phase squirrel cage induction motor is permanently shorted. The bars which are housed in the slots, those are permanently shorted with the end rings. As due to the rotor resistance or external resistance that we can add in the rotor circuit, due to which the slip ring induction motors are normally used for high starting torque application. And the performance of the squirrel cage induction motor is normally better if it is used for the low starting torque applications. As I already told you that the slip ring induction motor rotor involves a large number of parts, so the maintenance, so frequent maintenance is required. And the squirrel cage induction motor has very less number of parts, so its maintenance is very less. Again, the by varying the external resistance, we cannot only vary the torque developed by the induction motor, but we can also adjust the speed. And because of that, the speed control by rotor resistance method is possible only for the slip ring induction motor. But by this particular method, that is the speed control of the rotor resistance method, we cannot be apply this to the squirrel cage induction motor, because I have already told that we cannot change the resistance, rotor resistance of the squirrel cage induction motor once it is manufactured. So it becomes constant. And the last is slip ring induction motors are used where the high starting torque is required, because the starting torque is required only at the time of start. And that's why for the few applications, and that's why we can provide the required starting torque at the start just by inserting the external resistance in a required amount in the rotor circuit. But such kind of facility is not available in case of the squirrel cage induction motor. So the applications of the squirrel cage induction motors are limited to the low starting torque applications like the drilling machines, fans, blower and printing machines, whereas the applications which are requiring high starting torque, where we can use the slip ring induction motor like the cranes and elevators. Now this is about the construction and basics of the three-phase induction motor. I hope you like this, and thanks for watching.